Welcome back. Full hour. Next presentation is from JA Solar. We're really happy to have you here. And JA Solar will be represented by Tao Wang. He's working as a product manager with JA. He has been in the solar industry for over a decade, so we can call him almost a pioneer. And at JA Solar, his job primarily centers around the development of high efficiency solar modules, pre and post sales technical support work. So Tao is supposed to decode the customer feedback from product surveys and research work done by his colleagues so that timely solutions could be found and implemented. He will talk to us today about optimizing power density for excellent solar module efficiencies. Welcome to TaiyangNews, Tao. The floor is yours.
Yeah, also thank you for your invitations. For these online talks. Yeah. Okay, can you hear me?
Yeah. Yes,
okay.
I can hear you.
Okay.
You just share your screen and then.
Okay.
The moment it's black.
Let's check it to the full screen.
Perfect.
Okay. Can we start now?
Yes, please. Go ahead.
Okay.
The floor is yours.
Thank you. Thank you, Mike. So it's my great pleasure to use this TaiyangNews online platforms to introduce some technical details of JA Solar's 5 watts plus modules, which are based on the module design optimized for the integrated cost reduction of PV industry. So there are 3 parts of my topic today. First is the background introduction, then is JA Solar super higher power deep blue 3.0 module introduction, and the last is the summary and outlook. So first part, background introduction. In the past decade, the output power of modules have been on average increasing 10 watts, and module efficiency has increased about 0.6% every year. But since year 2018, the power of module has been increasing at a faster pace with large wafers and PERC high efficiency cell and a new module and assembly technologies like half-cut multi-busbar technologies. So now the made 460 watt modules have been recently in the mass production and available at JA Solar. And in the next few months, the mass production 500 watt plus modules will become widely available in the market. And this slide shows the cost for the tier 1 companies in the PV industry. Reducing integrated cost is very critical for ensuring the benefits of the customers. Today, the new cell technologies and various technical approaches of module assembly, including, as I mentioned, the bifacial PERC half-cut multi-busbar increase the power of module a lot, Also, you see the left slide to show you, the big size wafer improves the power a lot, and the drops the the LCOG costs rapidly. But the big size wafer not always the best. Later, we will explain how to choose the right size of silicon wafer suitable for the current industry situation. This slide, I talk about the LCOG trends. Now, from 2010 to 2018, the LCOG dropped by 77%, and this is the estimate from by IRENA. LCOG also expected to be further reduced to 3 US cents per kilowatt hour and 2 US cents per kilowatt hour in 2030 and 2050 respectively. So the rise of module power and the decline of cost is a fundamental of the development of PV technology. Now the second part I would like to do to introduce to use the latest J Deep Blue 3.0 series super higher products. So first, I want to talk about some design considerations here. So in addition to the high efficiency cell, we also when designing the modules, so we need to consider the limit of the module size, adaptation of the module and design, and upgradability of the cell and module technologies, and limit of the module power and integrated cost. Also, the advantage of the LCOE. Now, at present, we see there are mainly two types of we call a 500 watts versions in the market, such as the 182 wafer and 6 multiply 20 cells configuration, half cut version, and another is 210 millimeter size, and the module configuration is 5 multiply 10 with 3 cut version. And so compared with now the G1 and M6 silicon wafers produced from the size gap compared to current products, difficulty updating production lines and maturity of the device, and we think the product yield current also is higher at this stage. So from all these aspects, we think 182 size products is the best choice at the current stage. First here we see the module size is restricted by the the usable space of the container, as shown in this picture. The maximum module wise equals the height of the container door minus the double pallet height and operable height of the forklift. On the other hand, consideration should also be given to the supply of module glass. As we know, it is expected that rolled module glass with 2,300 millimeter length multiply about 1,150 millimeter width will be mass produced in the second half of this year. These two limitations allows us to get the maximum module wise. And according to the picture right, we get to know that 182mm size with 72 half cell is the current optimum pattern for power more than 500 modules. Here we show our Deep Blue 3-point products. First is use well-known PERC P-type PERC high efficiency mono cells. With this cell, our Deep Blue 3.0 module powers can reach 140 watts. JS Solar, as one of the earliest player in the field of cell manufacture, has accumulated more than 10 years of rich experience in various cell R&D and mass production. A series of high efficiency P and N type cell technologies with patents, including here the Persium, Cesium, Bicium, Rhenium, etc. Among them, Persium technology also first started mass production at JS Solar in the whole PV industry. And on the basis of the PERC high mono cell technologies, we also adopt Persium Plus super efficient cell technology, Blue 3-point series, which greatly improves the cell efficiency. Again, firstly, we reduce the surface area and improve the passivation effect on the backside, so that we could have a better long wavelength response, which lead to higher VOC values. Secondly, we have upgraded the selective emitter process, which widely applied at present to reduce the contact resistance of the metal and the semiconductors in front and back. So it increases the fear factor of the cells. At the same time, we use a new printing process on the back and to effectively improve the bifaciality and the mechanical load performance of the module. The series of cell upgrade technologies greatly improve the electrical performance, so make it possible to effectively increase the cell efficiency to more than 23%. So also, in addition to the high efficiency cell technologies, the wafer size upgrade also we see the improved module powers. So on June 23rd this year, JA, Jinko, Longji, Canadian Solar joint declaration will use 172mm silicon wafers as the standard size for the development and production of next generation wafers, cell, and modules to promote the whole industry to establish a supply chain system based on uniform standard, realize the standardization of manufacturing equipment, materials, and promote the healthy development of industry. Apart, from the module powers, reliability is also of great importance. And J also is the first PV company in the world to comprehensively apply gallium doped silicon wafers to high efficient PERC cells. which not only improves the cell efficiency, but also decrease the module degradation value in the first year to not more than 2%, and the annual linear degradation of Deep Blue 3.0 series single and double glass is not more than 0.55% and 0.45% respectively, which are the customer preferred products to guarantee the power generation yield. Also, our Deep Blue uses the multi-bus bar technologies. As we know, the first is the multi-bus bar use the circular ribbon and reduce the shading areas and improve reflect more light to cell surface and improve the cell efficiency and module power. Also, this multi-bus bar technology have less CTM loss by increasing amount of bus bar because of better cell current collection abilities. And last, short current path with more bus bar prevents power loss from micro cracks and broken fingers, which get 5 watts more improvement here. Also, we use the half cut technologies. As you see here, on a sunny day after heavy snow, the power generated by the half cell module is about 47% higher than of the full cell module. It can be seen from the comparison data of the working temperature between half and a full cell. That temperature of half cell PERC module is 2 to 3 thirds temperature lower than that of the whole cell when generation power. In addition, by reducing the internal current of module to half of the whole module, reducing the heat loss of internal resistance and current mismatch loss, the module power can be improved by about 10 watts. Accordingly, for our Deep Blue products, we also use the latest module technologies to improve the power. First, we use the double anti-reflective coating. We call the Arc2T series glass. This glass will increase the transparency to more than 94%, and will give the module power about 3 watts higher. And we also use the tiling ribbon technologies for some special orders, which tiling soldering technology. We optimize the optimal material and the best lamination process to reduce the power loss and the risk of macro crack. At the same time, the module efficiency can increase by another 0.4% to build perfect high energy density modules. Third, we have optimized the laser cutting process to reduce the laser induced damage. Moreover, we have upgraded the bus bar design. The specific number of the bus bar showing in here. And also the ribbon, with spatial surface structure are used to improve the optical absorptions and contribution to a power gain more than 1%. Fourth, we have improved the frame structures superior to traditional frame. We use the slot frame with patents and technology with lightweight and more convenient for installation and a better mechanical load performance. Deep Blue 3.0 will be officially mass production in Q4 this year, with a total planned the capacity to 14 gigawatts by end of 2021. Mass production power will focus on 540 watts for 72 cell type. Last is the summary and outlook. We see here, we compare the integrated cost of the wafer, cell, and module cost. We see the big size also save the cost a lot, but the 100 and 210 size can save the cell cost, but it will offset its advantage of offset by the disadvantage at wafer cost and module cost. Also, we compare the container, the module size of Deep Blue in the 40-foot container will have the maximum power more than 280 kilowatts. So it can be said that the present stage for upstream and downstream integrated companies, 182 size is the most suitable mass production products now. Now let's look at the system side cost. When we compare the 540 watt high power modules applied to the plant, we can see the support usage, inverter cost, installation cost, cable cost, all reduced. We also use location to the simulation. Choose a 360 megawatt plant at Dubai as an example. The project simulation use the single axis charter plus bifacial module. The result shows that using 540 watt modules, the plant capacity designs are more flexible, and compared with 400 watt modules, generate about 8 to 10% reduction of the LCV. Finally, power prospect is made here. 182 series module have abundant power expansion possibilities here. So on the 78 version, 182 series modules, there will be more plans, including size and wafer types, and a maximum power of module can be increased to 600 watts. It can be said that 40 watts is the starting point of current super high power modules. JA Solar will develop steadily and gradually introduce more and more excellent products to our customer in the near future. Okay, thank you. That's all.
Hi, Tao. Thanks. That was very interesting. Let's have some questions from the audience and also from me. I think maybe a first question regarding capacity. It was pretty impressive when you said that you want to have a capacity of 14 gigawatts for the new product. If I recall, JA's total capacity was 16 gigawatts end of last year. So that means when you go to 14 gigawatts, how much will it be of the total capacity that you will have at that point?
So estimate, not know exactly, just estimate. So by end of this year, around 20 gigawatts. So with next year we will expand our 182 size. We call it Deep Blue 3.0. So so of course nearly I think guys end of next year our capacity about 23 gigawatts.
Okay, so that basically two-thirds will be that product of the capacity then, 14 out of 23.
Yeah, yes.
Okay, yeah, very interesting. So just to, because
we also expansion very fast in recent years, because we have built some new fab. Currently new fab are always launch about at least 5 gigawatts start point.
Okay.
Mainly is 10 average mainly 10 gigawatts. The new
okay, super.
Yeah, yes,
okay,
yes.
Yeah, interesting.
Okay.
You also mentioned this 23% cell efficiency. So what if you look at power classes, how much of the output can reach such high efficiencies? For a PERC cell, 23% efficiency is very high. Huh?
Yes, you mean the cell power?
Yeah, no, I think so. If you look at the total production and how much of the power classes will reach that level, because I think typical PERC cell efficiencies are around 22-23% today, right?
22 to 23.
Yeah, that's a normal PERC cell efficiency.
Yes,
that's why this, yeah.
Yes, here I mentioned, first is the multi-bus bar. For the 5-bus bar, the as you remember, so the cell efficiency a little bit lower, and currently 22 point I think 0.3, something like this. But within the 9-bus bar, but big side maybe we use 10-bus bar, 11-bus bar. Because the wafer size bigger and the bus bar wise still same. The more light can to the cell surface. So the cell efficiency can go up to 23%. And also some because with the new fab built, the new equipment, and also with maybe with the better masks, better the cell process, manufacturing process. Currently, our latest cell lines, I already see the highest mass production cell efficiency and get 23.1. Okay. Okay.
That's impressive. Okay, good.
Okay.
You've started to use gallium doped silicon wafers. So did I understand you correctly? So that means all cells will be gallium doped, and as of when will this be exactly?
Yes. You know, we Jay have, you know, the currently have the deep blue 1.0, 2.0, and 3.0 series. That means G 1.0 is G1 size wafer, and 2.0 is M new size wafer, and then 0.3 is M10, as you know. And with all these wafers at Q3 this year, you all change to gallium doped wafer. That's better, you know, better for the module reliabilities and AID performance, anti-AID performance.
Okay.
Yeah.
That's very interesting. Okay. So you mentioned a couple of aspects also regarding designing 500-watt big size modules. Is there anything, any other factors beyond what you mentioned in your presentation that one should look at when designing 500-watt plus modules?
Yes. You know, we currently see some other companies some meanings for the 600, maybe more 660. But you know, first I think we needed to think those big panels, the weight, because as I know, the different country have the, you know, the label requirement, because you know the weight is too big. Maybe you need to use some machine, not the by manual. Maybe at some area is difficult for this. Also, when designing those big panels, we need to pay attention, you know, the size for compatible with the track, you know, single act tracks, because it's so big, maybe affect the steady or the safety of the track systems, because big panels, you know, the safety index will go higher. That means maybe your module cost a little lower, but you know, maybe bring the track system cost increase a lot.
Okay.
Also maybe some parameter designs. So for example, the VOC values, the current, you know, when panels so big, the current if so high, the safety we need to consider also. For example, the current, as I know, more than 20 amps, you know, the cable needed to, you know, pay attention with you know, the size, the closing size, maybe needed to evaluate it. Okay.
Let's stay maybe a little bit on the cells. A lot of people are interested in this high efficiency of the cells. So I'm not sure if you can answer that, but here is one question also regarding current. So increasing the current by multi-bus bars and so on. So PERC efficiencies can increase by that and the gallium doping. But how to come with PERC to over 700 millivolt and above? Because in the end, you would also have to go to passivating contacts, right? Are you also discussing internally N-type solar cells?
You mean our N-type cell?
Yeah.
Currently, we you know, quite long those N-type cell. In J we call it Bixion plus N-type.
Okay.
And the efficiency, I think, as I know, can get 1 point higher than the P-type PERC now, about 24% now. But currently, problem I think is still, you know, because you know the N-type, the wafer size not as fast as the P-type, so the power is a little bit low, and you know the whole chain, the cost, the cell cost are still a little bit higher, and that means making the P-type PERC have more advantage than N-type still now.
Okay.
You know, also you know, yes. Also now I mean with the you know gallium doped wafer mass production, you know, the AID performance also not still not a big issue for P-type now.
Yeah. But does so because gallium doping, you I think you signed this license with Shinetsu that you can use the gallium doping. I understand. Does it also increase cost now because to produce?
But just limited.
Okay.
Okay.
So the benefits are higher.
Yeah, benefits are higher. Yes.
Okay.
Okay.
There was one question, actually, a very practical one. Is the data sheet for the Deep Blue 3 already publicly available, or is it technical data sheets? Are they already available?
Yes. If a customer interesting, we can. I can send it to the target customers. Okay.
Okay. So.
Okay.
So I think we will distribute then your contact details so that people can get in touch. That's great news. What else do we have here? Yeah, there's also a question about what do you think, or at JA, what do you think are the most important factors for long-term reliability of high-performance technologies? So, because you also, when you look at warranties, so how do you make sure you can guarantee long warranties?
For example, I think currently, you know, more customers need, you know, the prolonged reliability test. When we first design, you know, our Deep Blue 3.0. So also, you know, we do those tests directly, you know, prolonged to maybe three times IC test to check their performance. Yes, and all the, you know, with the new IC standard also. Pay more attention to the reliability. We also actively try with our new products and to key important, of course, to improve our reliability of modules.
Okay. Regarding, I think, I don't know, that's also very technical. So I think you are using for encapsulations EVA. I think somebody asked if there are only, there's only also plans to use polyolefins instead, because that could have positive impacts on degradation. Are there any plans, or are you using EVA mostly?
And for the you know, monofacial, mainly we use the EVA, but for the bifacial, we J standard is use the POE.
Okay. Yeah.
Okay. POE. Because we see that in POE, yes, of course, can ensure the better performance, as you mentioned, the reliability. Because, you know, top glass modules we give custom 30 years warranty. Okay.
Okay. I think. Yeah, that's also an interesting question. So, how do you ensure that 500-watt plus modules meet the IEC standards in the Sun simulator and other accelerated testings? So, are there any? Yeah, please.
Yes, we already, you know, do those tests according to the IC standard for the like some simulation test, and we found no problems. They can pass those tests.
Okay.
Okay.
Maybe one more question. So why is the NOCT lower when you use half cells? Is one question.
Yes, as I mentioned, I think maybe then because the current is compared with 4 cells, the only half. So the internal we call it some resistance loss. That will cause the module temperature a little higher. That's will get the half cell will get the LCOE a little bit lower. But maybe I just test in this our R&D plant, but maybe other plants, some values maybe around 2. Maybe I mean we can collect more data. But average, I think 2 cells temperature, the gaps between half cell and 4 cell will be found.
Okay, yeah,
okay.
Interesting. Okay, so I think there's a couple of more questions, but I think some of them I want to keep also tomorrow for the executive panel, when we really talk a little bit about what the visions and the general trends are for the next few years. So Tao, thanks so much for being with us here and providing this very insightful presentation. I wish you a nice evening.